Welcome back to the lecture 23, which is week 5, lecture 3 of financial mathematics for actuaries. Today we are going to handle one interesting topic which is called deferred annuities. This typically relates to pension problem. We will understand what this problem is and why deferred annuities play a crucial role. In order to set the context, let us understand what is this waiting time trouble about. For example, if you have studied standard annuities, that means in earlier classes we have studied standard annuities, the annuities may start at t equal to 1 or t equal to 0. So, they are almost immediate starts. If you take a car loan, immediately you start paying EMIs. If you take a mortgage, you immediately start paying it off. Okay. So, these are our standard annuities. Now, let us focus on one new aspect where we do not want to get the, if we invest, we do not want to get the money right away. We will defer this, defer the payment, okay, or defer the, for example, educational loan, you defer the payment, right. So, it does not start immediately after taking educational loan, or if you are investing, you will start a pension plan which will have a deferred payments due. So, that's the problem that we are going to handle in this particular class, where you start after a delay period, and then in case of pension you work today. So, your pension starts at the age of 65, which may be at a time period 30 onwards, right. So, the core question here is, if my pension starts at t equal to 30, how do we value the stream of money that is separated from us by a gap of those 30 years, correct. So, that is the question that we are going to handle. So, in order to understand this, we need to actually visualize the deferral gap M. What is happening when in that deferral gap M? So, there we will, once we understand this deferral gap, we will deploy method 1, which is the discounting approach, which will be calculator friendly, and the other method, that is the subtraction approach, which is conceptual approach. You can try both of them, whichever suits you, you can use them, and then we will discuss one actual trap which is while dealing with immediate and due, how to handle that. So, it's when we are dealing with immediate, it's M, and when we are dealing with due, it is M plus 1, or vice versa. We will understand that trap explicitly, and then we will solve that trap, okay, so that you will never commit any such error in your exams. As usual, the reference mapping is Browerman section 2.2, Chan and Say sections 2.3 and 5. So, let us understand this deferral gap as the first bullet point in our agenda. Okay. So, now you have a new notation, that is M is coming here, then a vertical bar and then A angle N. This is saying my annuity is deferred by M time period. So, M is my deferral period and N is the payment term where I want to receive this annuity. Now, let us contrast this with our standard thing, like standard annuity, which where the payment starts at time point 1 and it continues up to time point 4. This is called A angle 4. This is annuity immediate for 4 years, right. Now, let us see if we wait for 5 years and move this stream to after 5 years, which is 6th year, 7th year, 8th year and 9th year. What will happen? So, I am waiting for 5 years, okay. So, this wait, and you know money has a time dimension, this wait should actually give me some money somehow, right. So, that is where we will look at how should I count these approaches, how should I count money in these time zones. Okay, so that's the first thing. So we will first look at the discounting approach, which is the safest method for calculation. First, you identify the local 0, which is you travel to the time m, okay, and treat that as your starting point. If you do that, then you have to calculate the present value at time point m, and for that I know all the calculations because I know how to compute annuities, right. So I have a angle n, which is the annuity at nth time period. The problem is I waited for these m time periods, right. So for to compensate for that, I will take a step 2, which is returning back this with this an value to the time point 0, and we already know how to do that because I have moved m time steps forward. So the discounting factor will play a role, which is v raised to m into a angle n. That will give me the present value. So nothing changes, right. So only thing is I have multiplied the regular annuity immediate by v raised to m. Okay. So what has happened? I went on to time m, then I calculated the annuity which was due for n periods, and then I moved back again by multiplying with v raised to m, and I got my final answer of present value, correct. So this is one way to do it. Next way that I will show is, okay, you look at this full stream where I have a full annuity to be paid. Okay, so now I will assume that I am paying it for all m plus n periods. Okay, so this is the full stream of annuities. However, the fact is that I have not paid for first m time periods, right. So if I have not paid for first m time periods, let me subtract that annuity from it, which will actually mean that I can compute annuity for m plus n periods, and I can simply subtract this annuity for m periods, that is all. So that will do my job, which is one of the easiest ways. You do not have to remember anything, but the previous method actually says you just calculate for n periods and multiply by v raised to n. That is also an easy way to do it. So you choose the method that suits you. Let us try to solve one problem which is like ambitious parent invested in child's future. So this is the 21st birthday trust. Okay, so the trust pays $10,000 for 4 years to a child, where the first payment is due on 21st birthday. So T is equal to 21. Interest rate in which this scheme is working is 5%. Effective annual interest rate is 5%. Calculate the present value of at birth. So how much the parent, the ambitious parent, should invest at the time of birth. Okay, so this is the question. So now this is a clear cut case of deferred annuity. Whether it is immediate or due depends on our context. Okay, so let us look at this and analyze this. So the first payment is due at t is equal to 21. After that I have to pay for 4 years, 21, 22, 23, 24, correct. So if I want the payment to be due at 21st year, when should this, if I am considering the immediate annuity logic, it should happen one period before the first payment, right. So I will look at time point t is equal to 20. Okay, by how much time I am differing? From t is equal to 0 onwards, right. So the deferral period that I am interested in is 20 years. Then I know what I should do. If I follow method 1, what is the way? It's basically I will go to that step where I have to compute this, and I will take that value and I will compute the annuity. Once I compute the annuity, I will bring that back 20 years. So, I will multiply by V raised to 20. That is all. So, step 1 is I will compute that annuity. You can easily compute A 5%. So, 1.05 is 1 plus I and 1 upon 1.05 is V. So, 1.05 raised to minus 4, and this quantity subtracted from 1 upon 0.05 will give me this answer, which is around 0.35 or something. So, that gives me 35,460 as my answer to the first step. And then what I need to do? I need to bring this back 20 years to time point 0. So, PV0 will be 1 upon 1.05 raised to 20. This is what it is, right. So, that gives me the answer 13,364.50. Okay. If you want to use calculator, you can easily use calculator. Type n is equal to 4, I by y is equal to 5, PMT is 10,000. You will get present value in the negative form, okay, and that is minus 35,460. So, the future value is minus 35,460, n is 20 and your PMT is 0, and then you compute the present value, you get this value. Slight difference, but it is okay. Okay. Now, the question is, we used annuity immediate logic. What if I want to change this logic to annuity due? Then it becomes the internal adjustment. Okay. So, if I want to use this as the annuity due in the context of annuity due, the payments again are at 21, 22, 23, 24, right. So, they start at the beginning. So, what should be my evaluation point or the valuation point? That is t is equal to 21. So, what should be my deferral period? M is equal to 21. This is the trap I was referring to when I was discussing the today's roadmap. There, when I am dealing with immediate logic, I was having M is equal to 20, and here I am having deferral period of M is equal to 21. So, one period here and there. Okay. So, if I use this, then what should be my formula? It should be V raised to 21 A double dot angle 4. Remember the connection, A double dot angle 4 and A angle 4, how they are related? I will simply use that connection. So, this is V raised to 21 into A angle 4 into 1 plus I, right. What is 1 plus I? 1 plus I is 1 by 1 upon V. So, it will cancel this off and it will make this V raised to 20, okay, and again I am back to the same square one, correct. So, whether I use annuity due or annuity immediate, as long as my cut point is correct, I am having the same calculation done. Let us now do the calculation with this standpoint, but in theory what I have is the same logic. Okay. So, let us move on. So, now because I am doing annuity due, I have to evaluate PV 21, and then if I evaluate this PV 21, it basically becomes 35,000, which was my earlier sum, multiplied by 1 plus I, which is 1.05, and that gives me 37,233. Okay. It is just a matter of practice. Again I am dividing by 21 years. So, 1.05 raised to minus 21. So, again it will roll back to the same number, same answer, different intermediate steps, that is all. But in theory what we are doing, it is same, as long as you are having a good sense of which M you are using, okay. So, this is the trap that you should always remember, okay. So, the trap alert coming next is the first payment at t equal to 10, then what should be the M? If you are looking at immediate, it should be t minus 1, okay, that is the 9th period, and pay at 10th period. Okay, so your waiting time becomes 9 years. Okay. Okay, then if you change this, to due anchor, your waiting period increases by 1 year. Okay, and M is the time of the first payment. Okay, so that's the difference, nothing else. And if you follow this, then your payments your payments will start at proper time and there won't be any delay. So, it is the internal logic that you need to make clear, otherwise there is no trap as such. Okay. But remember, do not fall prey to this double dot thing. I suggest you to always go to our regular annuity immediate. Then we will come to our next problem, which is, this is about finite M. What if I want to convert it into a perpetuity problem, that is deferred perpetuity. So, payment starts at t is equal to m plus 1 and goes forever. How will I handle this, right? So, m is the time period at which I will up to which I will watch, m plus 1 is the time period the payment will start, right. So, naturally v raised to m into a infinity will be my answer, correct. There is no mathematics involved here, it is an intuition. V raised to m into a n was my answer when n was finite. Now, this n is tending to infinity. So, v raised to m into a infinity is my answer. So, what is a infinity? We already know it is 1 by I. So, again this thing is 1 by I. So, let us apply this to an example where we are dealing with scholarship fund. A scholarship pays $5,000 per year forever starting at t is equal to 5. So, the first payment is at t is equal to 5. So, if you are looking for immediate anchor, it will be t is equal to 4. So, your m is 4, correct. And if m is 4, I know how to calculate. I will just go 5,000 by I into v raised to 4. What is v here? Which is 1 upon 1 plus I, correct. So, there is nothing great about this. If I want to extend this logic for continuous deferred annuities, then what will happen? I will be replaced with delta, right. So, it is 1 plus I which will be replaced with e raised to delta, and therefore, you have that discounting logic which is e raised to minus delta t dt from what period to what period. Till m you have not calculated anything, right. So, from m to m plus n, that is all, nothing else changes. However, now you want to discount this backwards, right. So, this is the discounting method, and therefore, the final answer is v raised to m 1 minus v raised to n by delta. The logic is identical, you are calculating in continuous blocks and then discounting it. Okay, now that we have understood how to deal with various deferred annuities, it is time for you to try your hand at pension planning problem. So, here is a scenario, current age is 40, you are expecting a pension of 50,000 per year. The first payment is due at age 65. So, you have 25 years in the buffer. Payments will be due for 20 years. So, it is a finite annuity and the interest rate, effective interest rate is 6%. You need to find the present value at t is equal to 0, which is age is equal to 40. Pause the video, do the problem, we will walk through the solution on the other side of the video. Welcome back. So, I hope you must have tried your hand. Let us see how well it went. So, first our problem is first pay is after 25 years, correct. We will follow annuity immediate logic. So, the valuation period or valuation point that I will look at is 24 years, t is equal to 24. So my M, that is the deferral period, will be 24 years. No brainers here. Then what do I need to do? In step 2, I have to calculate this annuity for 20 years at 6% interest rate and then multiply by the value 50,000 that I want at that particular point. That will give me the present value at the age of 64. That is what we will do now, and you can see that the clean calculation will give you this answer. Okay. What is the next step that we want to do? We are at the age of 40 and we started this investing. That means I have to discount this by my valuation point, that is T is equal to 24 or M is equal to 24, right. So, I will discount it by 24. Interest rate was 6%. So, 1.06 raised to minus 24 is the factor that I will multiply for with this 5,73,496. If I do that, I get 1,41,641 as the present value of that for that pension planning. So, this much I need to put in so that I will get some amount of 50,000 per year for next 20 years, correct. So, we have done a lot again today. So, let us try to summarize what we have done in today's lecture. First, we handled the concept of value at the start of the stream, which is local 0, and then we discounted it to global 0. So, that discounting method gave me this formula, which is M vertical bar A angle n is equal to V raised to M A angle n. Okay. So, trap is how to set this counting point M. Okay. If you are looking at immediate annuity plans, M will be start minus 1, where the annuity is starting minus 1, and if you are looking at due plan, M is equal to start. If you do this correctly, if you stick to only one logic, I prefer immediate logic, then you will never commit any such mistakes for deferred annuities. Okay. So, next coming up is we have done lot in annuities and perpetuities. Now, we will solve the problems where we need to deal with time period and interest rate if they are unknown. How to handle those situations? We have done that in our one-time payment system where we were calculating interest rate and how long will it take to double. But now, with this complex annuity mechanism, how will you solve for these unknowns? What are the tricks and tips for solving those unknowns is what coming up in the next lecture. Thank you.